Similar and congruent figures. Last thing in Unit
8.
8. Last thing in Unit 8, geometry. Got some rollback from last semester. I'm going to kick you in the tail with it. So we'll be ready to get kicked in the tail. So here we go. First thing, similar figures. Two figures. Now I want y'all to help me. What do you think? Two figures what?
That are the same.
That.
Close.
Are close.
I'm not. We got to be more specific than that. Come on now. No, that's the next thing over here.
Similar.
Well, that's what we're trying to define.
Look alike. Almost.
I got to be more specific than that. I want to be more mathematical than, oh, they look alike. How about?
They are similar.
Can't use the word similar in the definition.
Imitate.
Two figures that have.
Alike attributes.
The same.
Oh, I like that, but that's too much.
Okay.
Same.
All right. Two figures that have. Here we go. The same shape. Two figures that have the same shape, but not the same size. Very good. But not the same size. Now, put in parentheses, what does that mean geometrically? What we've learned about figures. Can we guess? Maybe not. Angles are same, but, okay, but side lengths, what about the side lengths?
Different.
But the side lengths, different. When you have similar figures, those angles in the two figures will be the same. That's what makes it alike figures. The problem we have is the lengths of the sides will be different. In other words, one is a miniature of the other. They look the same, but one's a miniature. For instance, big rectangle, a littler rectangle. Alrighty. Alright. Alright. Get the idea there. One's a miniature of the other. One's a miniature. Okay? Alright. Now there's something some people say neat about similar figures, and some people say, oh crud, they are something. And that's where our star comes in here. Similar figures are
Always.
and here's the blast from the past. Here's something we better remember from first semester, because here it is to kick us in the batiscus. Starts with P, R,
Prime.
O,
Professional.
Protractor? No. Proper. No. Proper.
Proportion.
there you go, somebody did it.
Allison.
Proportional. Similar figures are proportional. And we worked with proportions last semester. Oh, but we got to remember them because they came back to haunt us. In other words, remember a proportion is what?
Two equal fractions.
Two equal fractions. And we worked it knowing what some of you said a minute ago. PhD. PhD. Play how did. That's how we worked proportions, wasn't it? So we've got to remember something we've already done. We're just having to get it out of pictures, geometry pictures, and then we do what we've already learned how to do. Okay, so if we look at this, here are two figures. They have lengths of sides on there. We can set up a proportion to see if they are actually similar or not. Because if they're going to be similar, their side lengths need to be proportional. So, Trey, help me set up a fraction with this right here.
16 over 10.
16 over 10. Do we like what he's done? Yeah, I like it too. He took the same numbers from one of the pictures. 16 over 10. Now, he has set what we need to do for the next one. It must be identical. What side goes with 16 on the smaller picture? The 8 one. So that tells me the 8 needs to be on top, which leaves what for the denominator? The 5. Does that correspond with what the other one is? 10 is the bottom one? 10 is the bottom one. Okay. Now, is this one PhD? How did 16 turn into 8? Did this get divided by 2 to get a 5?
Yes.
This is a proportion, right? You can PhD it. So, yes, these are similar because they are proportional. Bless you, ma'am. They are proportional. They make a proportion. Okay? Now, look at this one right here. Luke, can you see that one through Brother
Yes.
Walker's head? Okay, you're fine, Walker. I'm just messing with you, dude. Because you're fun to mess with. You hate me now? Okay, good. You do? Can we set up a proportion here? Brother Walker is going to help me because I'm going to make sure he still likes me. Let's set up one here. What we got, buddy?
12 fours.
12 and a 4. Could I put 4 over 12 if I wanted to? Yeah. But Brother Walker wants the 12 on top, 4 on the bottom. That's fine with me. Now, what goes the same side as the 12? On the other one? 9. Do y'all agree 9 is the same as the 12 over there? And the 3 is there. When I try to PhD this one, how does 12 turn into 9? How does 4 turn into 3? Is it PhD-able?
No.
Oh, crud. So PhD is not always helpful. So, we got another star down here that says what, Emily? If PhD don't work, we got to try something else. Yeah. Ran out of room. Oh, that G's terrible. Try simplifying both of them to check it. If we can get them to simplify into the same stuff, then it works. So PhD sometimes works, sometimes it doesn't. If it doesn't work, we got to check one more thing, and that's simplify. So, what does this simplify into?
Simplifies into 4. 3. 3 over 1.
3 over 1. We divide by what? 4 divided by 4. and we got 3 over 1, right?
Correct.
Why can we simplify this?
3.
And what do we get?
3.
3 over, do you see
Oh, it all clicked.
that that is exactly the same as that?
Yes.
If that and that are the same, then yes, these are also similar because they're proportional. Even though PhD didn't work. I can't PhD this one. So I have to try something else. If you can get them to simplify, you got it good. Did you know there's another way of doing this too?
No.
Cross multiply.
Just yes.
If I can cross multiply and they equal, then they are similar or proportional. What's 3 times 12?
36.
What's 4 times 9?
36.
So there's another star I could put up there, right?
So,
You can cross multiply and check it.
so if they're not proportional,
These won't equal.
and what if they don't equal?
Then you say, no, they're not proportional, they're not similar. Okay? Alright. Am I okay with that?
Yes, sir.
Knowing that they are proportional helps us if part of it's missing. If we know they're proportional, we can find the missing part. So I just come over here and do fraction equals fraction. Let's make us a fraction. Christy, what do you think, girl?
25
Over
over 5.
5.
And x over 1.
Why'd the x go on top?
Because it's the same side as
Right, the x is the same corresponding side as the 25, so it's got to go in the same position. Good job, Emily. Been sleeping till about 10, getting up playing in the snow, so now you're tired right now because you had to get up early this morning. Me too. I've been sleeping till about 7:30. I usually have to get up at 4:45, so I'm tired this morning. I don't know, that stinks. Can this one PhD?
Yes.
How did 5 turn into 1? Divide by 5. Divide by 5, what do you get? The missing part is 5. Remember, what we're doing is finding the missing part. The missing part is the letter, x, the variable. 5 is the missing part. Can I cross multiply and work this one?
Yes.
Smart kids, watch this. 5 times x is 5x. 1 times 25 is 25. 5 times what gives me 25?
5.
So the x has to be 5, same answer.
It's algebraic.
It's algebraic. Algebra. Right?
Yes, sir.
Now, if I blew your head out, don't worry about it. You can always do a PhD. Okay? But when you get to the 7th grade, you're going to have problems that won't PhD. You're going to have to learn algebra.
Yes.
Cross multiply. Okay? All right, next one. Let's do this one. Find the missing part. That guy hanging there. 12 and the x.
36 over 48.
36 and the 48. Do we agree with Brother Clayton?
Yes.
Okay. Will this one PhD? I think it will. A lot easier than algebra because I'm about to get 36 times x equals, oh my goodness, 12 times 48. That's a big number. I don't know what that is. PhD. How did? Times 3. So something times 3 has to be 48.
48 divided by 3.
Or 48 divided by 3, which is,
16.
do we all agree the missing thing has to be 16 to get us 48?
Yes, we do.
So since we know similar figures are proportional, we can find missing parts by setting up a proportion. Now class, dost thou realize, we've already done these last semester. We started off, keep it going girl.
1455.
I don't care, keep it going. Keep it going. Notice, this is what we were given last semester, right? As a problem. Work it out. Well, now we just have to get the problem from a geometry picture. So are we really doing anything different? We're doing exactly what we did last semester, and y'all did good on it. We're just having to pick it out of a geometry picture to set up our problem, and then we find the missing part. So really, it's nothing new, is it? Well, the only thing new about it is set it up from geometry. Okay? All right. Last thing, congruent figures. What does congruent mean to y'all?
Same as, same size,
Nope.
and shape.
Nope.
Oh, dang it.
Nope, that's not what I said when
All
we
sides
defined.
are congruent.
No, I did not say that. What is congruent from right now in our geometry definitions?
Same size, same shape.
Nope.
That's what I want.
Nope.
Same.
Nope.
Equal.
Thank you very much. Remember, it's our geometry equal. I said as of right now, what is it? I haven't told you the new one.
That's what I want.
Ah, see? Congruent right now, we've had before. We had a picture, a symbol for it, didn't we? Remember that symbol? I want to know right now, what does congruent mean to us? And it's the same as equal, right? So congruent figures technically means equal figures, but I want to write what Tibbs was saying, so it has the same wording like similar figures. 2 figs. What's figs?
Figures.
Figures, that's our abbreviation. So 2 figs that what? Have
Same.
the same. What? Same what?
Same size and shape. And angle.
Same shape and same size. 2 figs that have the same shape and same size. Oh, yeah, look at it. But what does that mean geometrically?
Same angle.
Angles are same, comma, side lengths are what? Same. Well, that's some hard stuff right there now, by crackies. 2 pictures that are exactly the same. Now, does it matter?
No.
That's not the same size. But you get the idea. What if I flip one over?
It would still be same size.
Doesn't matter, right?
We're not gonna